Hi everyone. In this chapter, we are going to talk about custom errors. So why we need custom errors? If you had any errors like something went wrong or 404, you would know that how hard it is to debug a generic error. So whenever it says something went wrong, it's just saying that something went wrong, but I'm sure you're gonna find it. And that's the place that we lost most of our time. So defining custom errors is basically giving us clues so if something wrong happens with our code, so we can go back and see what's wrong with these clues that we left for ourselves. Now let's start by defining custom errors. Let's define our first custom error in a function and let's see how we can work with it since we have been already doing this for a while now. For this I'm going to create a function called divide. Inside this I will have numerator, which is f64, and denominator, which is also f64. And we are going to return a result here, and inside this result we will have either f64 or we are going to have our error as a string reference here. As you can see, we have a problem, and it says that we need to use a static lifetime, and the reason for that is we are actually telling Rust that we are going to return a reference, and then Rust tells us, okay, how long do you need this? We need to answer this question so that Rust can be sure that this reference will be valid for our use. For that, I'm going to say static here, so Rust can know that this will be for the entirety of the program. And inside this function, I'm going to say if denominator equals 0.0, then we are going to say error, and inside this error, let's say you cannot divide this with 0. And for the else case, we are going to return our calculation, which is numerator divided by denominator. Right. So this is the most basic usage of custom errors. We have been using this for a while. Now we are naming this as a custom error because for this divided by 0 error, actually we are creating our own, and for that we have you cannot divide this with 0. So this is the most basic usage of our custom errors, and let's see more advanced one now. Here I'm going to create an enum and I'm going to say this is rocket error, and inside this enum what we have is out of fuel, navigation system failure, and for the last one we are going to say alien invasion, which is always possible. Alright, we have our three different cases. Now let's create a function that makes use of it. Here I'm going to say handle error for this one, and let's say we will have an error which is rocket error. Let's create our cases here with the match statement. I'm going to say match error, and our first match arm is out of fuel. If it's out of fuel, we are going to say println Houston. Let's say we don't have any fuel, come and get us. Well, it should be a bad situation. Now let's create another one. For that one we will say we don't know where to go, Houston, our navigation has failed. For the last one, let's say the alien invasion, we will be saying I got a couple of aliens here. Do you have any questions, Christian? Because I'm pretty sure that they have many questions about the situation. So as you can see, if we have any problem with our project with this rocket, by defining this rocket error and handle error, we are saying that we want to know the error specifically. Instead of saying something went wrong, we are saying, okay, we have an error and that's an out of fuel error. And we have an error for the navigation system failure and the alien invasion. So if something goes wrong, we can look at this code with the output that we are getting and we can identify the problem, which will be much easier to solve it. Instead of putting time during the debugging problem, we are constructing code in a way that we would know what's going wrong with our code instantly. And by doing this, we are not only defining the specific problem, but we are creating for ourselves a place that we can actually fix this problem. At this point in this scope, we know that we have an out of field problem. So if we know that we have an out of field problem, we can have some code here which adds fuel. If we know that we have a problem with the navigation system failure, we can have a code that fixes this or does something about it. And for the third one, I think we can't do anything if aliens invade us. So we can just leave this like this to let everyone know. Alright, so by creating this structure, we are again specifying our problem, but not only specifying, we have an opportunity here to create an autonomous system which can fix the problems that is encountering with our manual interaction. Alright, this is a more advanced way to create custom errors. Now let's see how we can use this. I'm going to say let my error here, and it will be a rocket error, and let's say alien invasion. And here I'm going to say handle error, and I will pass my error here. Now if we say cargo build, and then say cargo run, we can see that we got a couple of aliens here, and we are asking if Houston wants to meet with them. So that way we can specify our problem. Now let's look at a more advanced example. Now we have our example. Don't worry though, I know it looks like a lot of code, but we are going to explain this, and we will be creating an example in the main together. So first, let's check out what we have here. We have an enumeration called my custom error. And inside this we have three different fields, which is IO, parse, and other. With the IO, what we have is std IO error. So we are getting error from IO, which is in the standard library. So what we are doing is we are actually passing values. So if it's an IO error, we are going to pass with the IO. If it's parser, we are going to pass with the parse. And if it's something else, we have the other for that, and we are going to carry the string here. So as you can see, with the parse, we have std num parseInt error. And with IO, what we have is the IO error. Now let's look at this part of the example. And after we understand this part, it's going to make much more sense. So let's see what we are doing here. First, we are implementing display for our custom error. We are implementing display for our error because we are going to use this as an error, not normal enumeration. In the previous examples, what we did is we created our own custom error types, but they were just the enumeration that we used as an error. For Rust, they weren't errors. So what we are doing here is we are creating error that Rust actually sees as an error. For that, we need to add a couple of traits, and trait for us to make our enum error in the eyes of the Rust, we are saying implement error for my custom error. As you can see, we didn't add any function here because it's not required by the error trait. We are implementing this trait for our my custom error, and then we will have the functionality of the errors without implementing any specific function. That's because they are not required by the error trait. Now we have our enumeration here, and it's an error for Rust. And here what we are doing is actually we are implementing this function so that our errors can be easily understood. So our IO wouldn't be helpful very much, but from the FMT we are implementing this display trait for our function. And for that we need this format function. In this format function, first we have self, and next we have a formatter from this format library. And then we are going to return a result from this format library. So we are matching self here. So once we said match self, as the self, what it's talking about is that this enumeration here. So we have three different fields, so three different match arms. In the first match arm, if we have an IO error and if we have this ERR as the value, we know that it's actually an error from the standard library. And if that's the case, we are going to say this is an IO error and this is our error. And we are going to implement this for the others. And then we created a function here, and the job of this function is to read from a file. And if the file does not exist, then we are going to throw an error. For that, we have our file name, and we are returning a result. It's either I32 or my custom error. So we are getting the content here from using the fs read to string function. This is from a file system library. By saying read to string, we are reading the content of this file that is provided to our function as a parameter. And then we are mapping the error here by saying map error. we are actually saying that if we have any error, then we are mapping it with our my custom error. And we are using this question mark at the end. So if this goes wrong, then we will have our error. Then we will be able to return this as a result here. By defining our custom error as an error, we have this functionality here with question mark. And then if we were able to get the content, we are getting rid of the spaces using the trim function, and we are actually converting this content to an integer, because we said that we are going to return an i32 integer inside the result. But if something goes wrong again, then we are mapping this possible error with our my custom error, and if there is something wrong with the parse process, we know that this is the parse part of our process, and that's why we are using parse field with my custom error enumeration, and we are returning a possible error with a result. Now let's make use of this function, and again we have a custom error. We implemented this display trait so that if we have an error with our custom error, we are going to write this in a nice, easily readable way, and we created a function so that we can use this in our main function to see how this works. So in this main part, let's create our function, and also as you can see here, we said use stdfs, io, and num. So we said we are going to use these three libraries which are required in the creation process here. In the main, I'm going to say match, read, and parse, and inside this as the file name, I'm going to say test.txt. I don't have this test file, so I'm expecting to get an error. Actually, we are all expecting an error in this lesson, I guess, but tricky part is to get an error that I want. So for the first match arm, I'm going to say if I have an OK num, I will say there is nothing wrong here. If not, if I have an error like this, then I will say an error has occurred, and we are going to provide this error here. So let's run and see. First, let's say cargo build. Let's say cargo run. And now as you can see, an error has occurred, IO error, no such file or directory. So this is actually an error that we are getting from the Rust, no such file or directory. And we are passing this error here with our std error. So we are putting this inside our IO, and since we are putting this inside our IO and we are using this my custom error, we have an additional information here saying that this is an IO error, because we said an error has occurred, and it says an error has occurred, but IO error, no such file or directory, actually comes from here. As you can see, we said IO error and we provided the error that we got from the Rust. And here we are providing the error that we got from the Rust, which is the no such file or directory. And as you can see, between the parentheses, it says operating system error 2. So we actually were able to alter the default behavior of this Rust error. So if we have a big program or a large project, we can create our own custom errors, or we can modify the ones that we already have with the Rust, so that we can have a broader understanding and usage of errors. I hope that give you a more insight of the possible usage of custom errors. With this whole process, I hope that you saw that how Rust can be really beneficial and really secure with handling errors and solving problems. So it looks like a little bit more job while writing our code, creating our project, but we are creating a system which can solve errors because it would know which error it is getting, which is memory safe. Actually, we are putting a little time in the beginning so that we wouldn't put larger time at the end. It's like creating an outline for your essay. You can write an essay without an outline, which seems like an extra work, but just by doing the outline, you are actually shortening the process. As we all know that we will have problems with our code, it's inevitable. Creating our code this way, we can utilize Rust features and also have a safe and reactive code. Thank you very much.